Okay, hello guys. It's the middle of the night and I'm trying to make a video of the reparation of this big ass power supply which doesn't even fit on the table. This one, on the other hand, was repaired before and now it's already plugged in, so it's working pretty much fine. So, okay, you can see it now. So everything works fine, blinks fine, clicks fine, and I mean, it's my usual linear power supply that I'm using for everyday stuff. This one, however, is a big brother, and as you can see, I bought it for 2,200 Japanese rubles or so. For foreign currency it will be like 20 bucks, less than 20 bucks actually. And it's sad, it's junk, don't buy it. But we can sell it to you if you want. But if you read Japanese here, yeah, it says junk. So the problem with it is the button. Remember the sound? It clicks. It doesn't light up because it's not plugged in yet. If I plug it in, so I can plug it in here, the clicking will change. See? It's a relay clicking here, but the scale doesn't light up. So the first thing I did was sniff it, of course. Just sniff its butt. Like, sniff it here on the grills. Usually when it explodes in a horrible way, it will stink like molten wax from the transformers, or sort of burnt plastic from transistors or diodes, and it will stink in a really horrible way if the capacitor explodes. Like, I don't even know how to explain this smell, but anyway, this shit doesn't work. So I'm going to pause the video, I'm going to move the camera above it, and we're going to look at it from the top, because right here I cannot see it basically because I will get in the way here. Okay, now we're in a more comfortable position to open it up. I'm going to use my cheapo wherever screwdriver. Kenwood was manufacturer of this beast, by the way. It's called Kenwood. They were nice enough to just use normal Phillips screws. None of that Torx or secure Torx rubbish. So it's pretty easy. 4 screws on the top, and then three screws on each side. Oh yeah, of course. You see the warning. You know what you're going to do? I'm going to disconnect this. Always disconnect it first, and from the power supply itself. Has a really nice connector. Standard, I would say. So actually I was kind of delaying making this video because I didn't know how to do it and didn't know what to talk about and stuff. But in the end, if I don't try making it, will not try to upload it, how am I going to know what you want? My goal in general on this channel will be to show you stuff. I mean, I work in a lab, I repair shit at home, I travel, like in Japan, I cook, I do whatever. And I saw many people interested in that on other channels. So I decided to make my own. And this one just basically lifts like this. Okay. going to put the screws in a really small and nice bowl here on the side. We are going to look at the stuff which was clicking. I strongly believe that it was this relay. So, as you can see, we have a shit ton of stuff here. Basically, it's the measuring and controlling circuit here, stabilization. Oh, by the way, this power supply, it's also bipolar, so it has 2 ports on the sides. Yeah. How much was that? 8 volts 2 amps, 18 volts 2 amps, 36 volts 1 amp. Here. So probably this, yeah, probably it's 1, 2, 3. This is the bipolar part, and this is the 36 volts part, or whatever. I don't know actually. It's the first time I take it apart. So, where do we start? I would probably start looking at the relay. No, first you have to start with the fuse. Fuse is here. It's not blown, so probably it's fine. Yeah. Next, I would like to look at the relay, but it looks like we can remove it only if we remove this huge radiator, which can be removed from here. So my actual goal is in this channel will be to show people how you can repair stuff without even knowing much about it. No, this can be pulled on the side, I guess, just like this. Oh, it can be even placed on the side. Oops, sorry for the loud noise. Okay, placed on the side. Now we have 2 relays here, this and this. I didn't even know there were 2. Okay, now, disclaimer, don't do this at home. I'm going to plug this in, and first I want to know, are those relays doing anything or not? So, I'm going to start tracking down the problem with the working part. So, if the relay works, it means signal is coming to it. However, if in the boot up sequence, if this relay is the first one, then probably nothing will come out of it, and nothing will light up. Also, as we can see here, nothing is horribly exploded, so probably it's the problem somewhere in the beginning. Okay, so plugging it in. No, by the way, the radiator was grounded to the case, so probably the radiator is not going to have any power on it, and this part is not connected to this board, so it's fine. I mean, it's not touching, it's hard to see. Oh well. Okay. Now I can clearly hear that these 2 relays are clicking together. So they do click. And then it would mean that this so probably, oh, I can see it was soldered here. I wonder when it was. in the factory. So I'm going to actually Google. I'm going to Google that. Wait a second, I will come back with the schematics or without one. Okay, guys. Yesterday I was trying to look up for the schematics of this beast, and I couldn't find anything, which is sad. Oh well. So I went a bit overboard and just pulled everything apart here and understood a bit how it works. So basically this is the main switch, which I was clicking in the very beginning, and it doesn't go to the main board. So this part, the front part with the, so here is the main processor. It's actually a microprocessor, basically the whole brains of the operation, and in two PCBs here. Then the power distribution board, the main transformer. This probably some sort of controllers or stabilizers for current or voltage. I didn't get it yet. And the main power transistors are here, and this looks like some smaller version of this board, because the layouts of this one and this one are completely the same. So it's the same PCB but different components. Here is the same, so same PCB, a bit different components. So the logic goes like this: power switch is here, then it goes through the fuse to the input of the transformer. Oh yeah, of course, like it goes from the AC input, line voltage input, through the switch, through the fuse in the transformer. From the transformer it goes to this board, like the relays that we're clicking, and they are supposed to supply voltage with these two, like so. There are two power cables here, and it's pretty hard to see. Let me move it. And here, and they are controlled by this braid of wires. Oh, this is the voltage input, these two are voltage output, and this braid probably is the control. Also, part of the AC comes from this side and goes into the power distribution board, and also this is mostly the controller output here. So we can see how it looks. So this is mostly like logical or analog output, but this is power, and it's parallel to this part here as well, and it just goes out here. However, when I turn on the power, the power is not here, and this power is for sure needed for the operation of the main processor, so it's not the processor shutting it down. That's why we're going to inject some power using this small power supply. So this is a blue wire and a red wire. The problem is that we don't really know the polarity. If you don't know the polarity on a logical circuit, just open it up and trace it to the closest capacitor. So here, as you can see, focus. Okay. So here, as you can see, the red one goes to positive side. It's even like plus on the mask here. And the blue one goes to the negative side. It means that the blue is negative. So we can just connect red to the positive, black to the blue, which will be negative, and turn on the power. So yeah, it tries to show us some sort of error. Yeah, probably it says that there is no power on this controller boards, and actually I have disconnected this from the power distribution board here because I can and because I don't want to feed any power through this mess here. So the next thing I'm going to do is turn off this, of course, and I'm going to actually remove the power distribution board and check how it works, because this one is coming straight from the transformer, and when you disconnect it, it has 9 volts on it. Strangely enough, I was expecting it to be 5, but well, and it also goes through some sort of voltage stabilizer under. I will show it later, so just give me a second, I will take it out. Okay, I think I understood how it all broke down. So I started by removing this board. No, let's just disconnect it here. And we know that 5-volt power has to be coming out from here, so this was connected here. So first 2 pins on the left, 2 pins it's hard to zoom down. Okay, so here we can see that there are 4 pins, but 2 on the left and 2 on the right are paralleled, like here, so they're going to the same pins. And we can trace it so these 4 pins, and we can actually use a tester to trace it to this tree. So this one is the red wire, or no, it's a brown wire. It's a brown, red, orange, and it goes in like this to this mysterious part. See, like, it's not even exploded. There is a bit of dirt here, but I don't know. The part itself is pretty much fine. The only problem is that I thought it was some sort of voltage regulator, like LM317 or something, but apparently it's not. It's let me read it to you. It's 7605A GRC. And if we look at the datasheet for it, it is apparently a standalone voltage regulator, as expected. So it gives us how much? So this is the package, and we have, so it's basically 5-volt constant output, 1.5 amp max or something. Yeah, it said here 1.5 watt maximum, power dissipation 15 watts. That's why it was covered with thermal goop, whatever. I mean, 15 watts, come on, it's nothing. And yeah, 5 volts output, and the important part here is maximum input voltage of 36 volts. So I decided, well, there is no regulators here anymore, so these are the basically, so this is simply like the decoupling photo, like octopairs, some sort of logic, whatever. It's not power dissipating at all. Like shit ton of relays, huge relay, a lot of inputs, and basically nothing else. The other side is positive. So if the power comes from this board, it has either to come from this regulator, or it has to come from this, like from those bigger boards. The problem is that those boards are dead, so they basically need a command. They need a logic level or some sort of ISP signal from the main brain board. And the brain board, we know, is not powered. So even though I didn't connect any logic analyzer to this braid, we know that since it's not powered, like, it's bound to be no signal here. I mean, I just tested it with this shitty tester. It shows something. If there's a logic signal, it would show like blinking or whatever, but no. So like, there's no input aside from this one. Oh, and this pair actually, it's a logic pair, so it's just data going out to some sort of max microchip all the way back here. It's just logic. Basically, it is possible to connect this to another power supply, so daisy chain, or connect it to the GPIO of some sort of like controller or whatever. So it doesn't matter. Like, we can disconnect it; it will not change anything. And the thing I decided to do is just to test it. So since I have this small, let me actually put it like this. Okay, I'm going to do it like this. I'm going to move this part here. I'm going to put this on its back. It's fine. So you can see the voltage more or less like this, and you can see the shitty Chinese IM tester. And from the data sheet, we know that here, so you can see the data sheet, it says output common input. So we know the pinout, and we can just simply test it. Not gonna lie, I did it before. I even played with something else, but I want to show the way of thinking. Like, the problem with this video is that it's actually pretty hard to film, because it takes quite a lot of time to think about this kind of stuff. And for example, while playing around with this kind of power supply, well, not only takes time, but I cannot really express what I'm thinking about. So yeah, we see this is the power input, so this is input, common, and output. And the common is connected here, and the common of the tester will be connected here somewhere. It's common rail, and the output will be to the output. So the current protection is off, it's all the way to the max, and we just, for example, we will start from the low voltage output. See? Like, I don't think it's supposed to give us any voltage below 5 volts. And we can slowly increase it. Okay, it went up 5 volts. See? And this is normal operation for it. So it has to stabilize 5 volts. Oh, it's not getting warm, by the way, it's fine. It's supposed to stabilize, so let's increase it. 7 volts, 8 volts, 9 volts, 10 volts. Oba! See? And this is the failure mode of this stuff, of this component. So it was absolutely fine to the 10 volt mark. And the second we go above it, it just drops to 0. Here, I will just turn this off. Here, this, I think it comes from this gray line here, and it gives us 9 volt AC, and then it gets rectified and pulled through this huge cap, so it will be above 10 volts, just above 10 volts actually. So yeah, this is a pretty weird failure mode, I would say. But okay, like, maybe I'm wrong, right? How do we check ourselves? I mean, I don't have a stash of this like weird obscure piece of shit component. I'm not going to make it from transistors or whatever. I'm not going to like solder together 350 op amps to make this stabilizer. I mean, yeah, you can make it easier, but come on. So the easiest way, like since we know the polarity and since we, like from the datasheet, we know that the output voltage of this part is supposed to be 5 volts exactly. So 5 volts plus minus 4% tolerance, I think. Yeah, it's 4.8 to 5.2 volts. We can just basically use this small brother of this big power supply, just inject some voltage into it. I have to mention though, these power supplies, you can see, they're fully isolated. So the primary of this power supply is not connected in any way, shape or form to the secondary. So there's no like, there's no capacitors, there's no sensing, there's nothing. So this goes, so the power line goes through here, through the power button, through the fuse, in the primary. That's it. It doesn't go any further. It's the same with this one, because I took it apart before, and basically it's just the shrunk down version of this one, and it has like maybe like quarter of this board inside as well. This power supply just had a problem with the display. It was oxidized in contacts, and the board was just, I think they spilled something on it, so I just had to apply some lacquer and remove the corrosion. It was fine. So like not even worth filming. So now what we're going to do is we're going to put this board together and we're going to try and inject some voltage. So just actually I'm just going to do it live. Should I ramble while I talk, while I do stuff? So okay, let's put this, like this is the screw from the stabilizer. I'm going to put it back because I don't want to lose it. I have enough shit on the table already. It's going to get lost if I don't put it back. Yeah. So actually the main point of this channel, at least in my thinking, is to show you guys the lab. I mean, now I'm filming from my home, yeah, but I want to show you the lab, like the semiconductor fabrication facility and stuff, but it really takes time. You should understand that. It really takes time to film, it really takes time to edit and other stuff. So I guess I want some positive feedback first, or negative, while we're at it. I want to check out how to upload to different platforms, such as like YouTube or Odyssey or whatever. We will see. So yeah, so this is basically just a testing video, maybe going to be like half an hour long. Yeah, considering that, spoilers, we're almost done. Oh yeah, and this logic braid, it has to go back. Also, this part, it doesn't only supply power to the brains, but also to the relays here. So we have to connect it back. And and this is the stabilizers thing. I will just leave it unconnected. And we will be injecting the voltage on these pins here. Let me just move the camera, probably, and I will show you how it works. Okay, a bit different angle. Let me just So first we want to regulate our voltage to 5 volts. I want exactly 5 volts. We don't want to blow it up again, right? Okay, 5 volts. Ooh, it's not as fine. Oh well, good enough. So, and then we are going to limit the current slightly. And now we are going to put these leads on these 2 pins here, because this powers our brain. Yeah. And also we are going, oh yeah, the reason I said that this power supply is isolated, and I stressed that. Don't do this on impulse power supplies, because they're connected to the mains, and due to a lot of weird stuff happening inside, they will just blow each other up with a pretty high probability if you do this. Yeah, like, shit will happen. It might work. It might work. Like, if you're careful, it might even work a few times, but one day something will go wrong, you will touch it in the wrong place, and it will just set the whole table on fire. It happens, but be careful with that. So, now, this power is off, but if I give it some power, see, it's fine. Like, it's happy little power supply, but it's like, it's unable to give out any power. It's like output protected and stuff. I mean, it works, yeah. Like, so the brain works, but the power part is without any power, because this is off. Now I'm going to turn this off. I'm going to turn this on. I'm going to turn this power and this power at the same time. Okay, relays galloping, it's good. Means something is happening. And we can really do something with it. So remove the output protect and so actually the first time I turned it on, my current here was limited to say the least. And when you turn it on, and it works no problem now. Yeah, it would just go do like this. Okay, so I remove current protect. Yeah, and it would do just like this. So I noticed that this clips to the maximum current, and I just increased it. And now it's time to check the voltage on this on the output. So this is a really strange power supply. It has so many presets. So it has quite a lot of presets, so which are actually not useful. I'm pretty sure you can change them, so you can rewrite them, but it's more of the review stuff. It's not my job right now. So right now I have connected to 18 volts, yeah, common and 18 volts. So we will be selecting 18 volts here. We're going to select variable, and this is on max. So let's put it on, for example, 15 volts and turn the output on. And awesome, isn't it? How this small power regulator can just bring down the whole power supply with it. Well, it brought it down safely, which I'm grateful for. I'm going to make it a king funeral. Okay, let's check another channels. So 36 volts, we drop in here, and we also increase it. Actually, you can do it the fast way. This is pretty sensitive. Okay. Right on the mark. Yeah, I gotta love these Japanese power supplies. Okay, and the last range, we are going to go for 8 volts, and 8 volts, it has a separate ground. So, we will go for it. So, the separate ground is here. And here. Yeah, pretty nice. At least it works now. I haven't decided yet what to do with it. Maybe I'll sell it. Maybe I will sell the smaller one. Maybe I will generously give it to my own lab. However, there is already a power supply there. So we will see. But for now, I'm going to find a replacement and probably make a review of this awesome big ass power supply. Yeah, maybe I should measure the pulsations, load it up, check everything, like power curves and stuff, like efficiency. Yeah, leave something in the comments. I'm still actually thinking what to make of this channel. So, thank you for watching. Or, yeah, thank you for watching.